Hi, Jonathan Godfrey, on-site wastewater professionals. Coming to you today for some exam preparation for the PCI or Private Compliance Inspector's exam. We're going to jump into what you need to know to do well on the Private Compliance Inspector exam. And this is going to extend not only to the regulations surrounding Private Compliance Inspector, but also some of the fundamental things you need to understand when you're doing system inspection of these advanced systems or systems permitted by engineers or AOWEs. Let's jump into it and get going today. So we're looking at all this is going to be Senate Bill 166, which became a law in North Carolina, Session Law 2024-49. So we got private compliance inspector is going to be a person hired to perform the private compliance inspection of a new on-site wastewater system, maybe a repair. You can do inspections on all kinds of things we're going to find out. So the applicant can contract with a private compliance inspector to conduct any of the required verifications. That could be pump finals, we're going to find out repairs, new construction, fill pads, all kinds of stuff. But there's some limits on what they can't do. They cannot perform inspections on permits that were born and raised, we're going to call it at the county or local health department level. So if there's a traditional permit pathway where a local environmental health specialist at the county does the soil work, does the design, issues the permit, that won't be eligible for involvement from a PCI. The things the PCI can do, they can inspect a hybrid style permit, so 135, 335, A5 permit that was soils and design were done by a AOWE and or an engineer. The PCI could step in and do that final. PCI can obviously do the final for an AOWE fully private permit, and they can do the final inspection for a NOI issued by engineer, NOI issued by an AOWE. Not allowed to work on the fully county traditional permits. The private compliance inspector, who can you be hired by? So this one, you got a wide range, very obstacles here. You can be hired by the wastewater system owner. So property owner can hire you. You can be hired by the contractor. The installer can hire you to come be the PCI. The engineer obviously can hire you. The AOWE obviously can hire you to do those inspections. All of these pathways are possible. Who can do this? So you've got to have 5 years of experience as an installer. Doesn't really say what grade level. I've got to have 5 years experience as an AOWE if I was using that as my pathway to becoming a PCI. 5 years experience as a subsurface operator. So 5 years documented experience holding a subsurface operator designation in North Carolina, or registered environmental health specialist with on-site wastewater training. 5 years of that experience will get you into the door and get you eligible to be able to sit through the classes and test to become this. But you can't be an employee of the local health department. And so we're talking about full, part-time, contract, anything. We can't be an employee of the local health department and still be a PCI. All right. You're going to conduct all these inspections, anything, but you're inspecting, and this is a key concept. Your job is not to go out there and redesign the system or critique all the design work or soils work done by the engineer or AOWE. Your role in this process is to inspect with the NOI or construction authorization. Make sure the installation is in compliance with the design. And so that's our job out here. You're going to be doing pump finals, making sure the pump and that pump system comply with the design as drawn up by the engineer AOWE. We're doing cover checks. Something as simple as making sure there's 6 inches of soil cover after installation could be taken by the PCI on these jobs. Fill system check. Is the pad the appropriate width, height, material? Is it integrated into the soil? We're going to make sure it complies with the design. And then the complete final. You could do everything. So you're not limited to just segments. You could do any part of it, or you could do all of it. Make sure it's compliant with the construction authorization or NOI as the engineer AOWE has drawn it up. All right. The private compliance inspector's got to have some insurance, guys. And so we're looking at errors and omission and general liability insurance. The rules describe this as sufficient for the work you're doing. It doesn't give me a dollar amount. It just needs to be kind of commensurate with the risk that you're undertaking. So, how big of jobs are you doing? That's how big a policy that you need. So, sufficient errors and omissions and general liability here. No indication of the dollar amount in the rule. All right. The owner of the property has to accept a private compliance inspector. So the owner may hire you, and certainly they would accept you then, but there is a board approved form that says, yes, I understand that the engineer is subbing out the final inspection activities to a third party PCI, and I consent to that. So on a board approved form, the owner is always going to consent to the PCI's presence in this operation. So here's our little board approved form, and owner hereby attest, private compliance inspector's name, and the signature of the owner representative right here. What else do I need in addition to that? Well, you've got to get written approval from the engineer or AOWE who birthed this design or project. And so we said you could be hired by the installer, you could be hired by the owner, but you can't be hired by them in a way to end run a difficult inspection. So it must have the consent, the written consent of the AOWE or engineer as applicable in these cases. So far, you've got to get a consent from two people on every single job. I've got to have the consent of the owner for the PCI, and I've also got to have the consent of either the AOWE or the engineer involved in this process. And there will be one of those in every one of these processes. Okay. So it's going to be on a common form developed by the NCOW CICB. And that common form for the final construction and permitting of this, the PCI uses is going to also include area where you're supposed to capture as-built drawings. These are going to be not only just a copy and paste of what it was designed to be, this is going to be what I saw on the ground. This is what got put in, and that should correspond with the design that you're trying to make sure things are held to that standard. So here's your board approved form, basic contact information on here. And then you're starting to capture some of the fundamental information about system from design flow, depth of aggregate, trench depth, distribution method, all the way through the details. We attest, you sign it, that you saw it, and then you're going to give me some as-builts that go along with this. So what is the time frame for submittal? So just want to take a thought real quick. How fast do I have to turn this in? In many cases, we've got these short windows. You got to turn it in when it's complete. I don't have a statutory time frame for when this document gets turned in. Now, if the engineer or AOWE is going to be waiting on this document before they can complete their ATO, and so the project is not going to move forward to CO to final completion until this is submitted, but there's no time frame. So if you think, well, I got part of the system finalized, but I didn't get the pump final. Well, we'll get it when the project's complete is when you would submit it. All right. You're going to deliver this completed inspection to the engineer or AOWE as applicable. We are going to send these to the owner, engineer, or AOWE. What we're not going to do or not required to do is the PCI will not hand deliver this to the local health department. The PCI will not hand deliver this to the building inspections department. This is part of the process that the engineer or AOWE are going to use many times to issue their ATO. And so we can't jump around them. So we're going to deliver to them. It is the owner or engineer or AOWE's job to then submit this information, the ATO, on to the county, but not the PCI's job to get it to the county. All right, the local health department, once they get the ATO, once they get the operations permit or ATO, it is their job to issue the operations permit. So if the engineer gets your document and then sends it on, They can't hold things up. Once they get that ATO, they have to issue the operations permit once it's complete. The local health department, because they didn't get a chance to look at the dirt, they didn't get a chance to do the design, and they didn't get a chance to do the final inspection, they of course are not going to be held liable. The general statute discharges and releases any liability responsibilities um, on a system inspected by a PCI, so that the local health department is not going to be on the hook for any problems here. That burden is going to shift over to the PCI and the AOWE or engineer. It's why they are going to be required to have insurance in this process. So, private compliance inspector, you got to do some training. How many hours of C do you have to do? When do you have to have them each year? To get this certification, you've got to do a 36-hour course that's board approved. You've actually got to have your CE hours. You've got to have 12 a year, and you've got to get them submitted by November 15th to be on time. So 12 hours a year of board approved continuing education. With the NCOWCICB, the hours are required to be in person. Online classes are not eligible for credit towards your PCI requirement. All right, so we're going to switch gears beyond the fundamentals of what a PCI can do, what they can't do. We're going to talk inspection stuff. What do you need to know in the field to complete final inspections and do your job? Basic information here. Let's jump in. So, drip irrigation. We're going to jump into drip systems. What do you need to know to do drip? Every design should specify the depth of installation, the installation equipment used, any blanking that's going to be used, how much and where, anything that they're going to use to prevent drain backs, such as check valves or earthen dams, will be delineated on there, and any other site-specific requirements. These are part of the design. This has to be captured as part of a drip inspection. So installation depth, what type of equipment was used, where was blanking used, any drain back prevention. So this is going to be part of every design. So we've got a system that's broken up into runs, laterals, and zones. So runs are a single length of drip tubing on contour, because drip does have to be installed on contour. Even though the emitters are pressure compensating and very fancy, we still put these on contour because when the pump turns off, all bets are off on pressure compensation. So the run is a single piece of drip tubing. When I connect that run to the supply manifold and back to the return manifold, maybe in a loop or may just be across the yard, it becomes a lateral. So when that single or multiple runs of tubing is connected, this connects the supply and return, it becomes a lateral. And then this group of laterals that we manage as an independent unit, we're going to call that a zone. So you may have a single zone system, but often we're going to have multiple zones. Inside of a zone, we'll have multiple laterals, and inside of a lateral, I may have multiple runs. So understanding the language is going to be critical to understanding what we're doing here. All right. When we talk about inspection, we're looking to make sure floats are set up properly in these systems in accordance with design. And it says really when we set these floats up, I'm not supposed to have any backup of wastewater into the freeboard space of the septic tank that would result in a disruption of gravity flow. And so if I'm trying to get my emergency storage in a pump tank for a drip system, I cannot see that water's backed up into the freeboard space of the septic tank. So in that pump tank, I've got to have pump submergence, dose volume, flow equalization, emergency storage, without interfering the performance of the pretreatment components upstream of there. So you see these floats in here, not using the freeboard space. I could use the riser space in some occasions, but we'll typically have a redundant off, timer enable, an alarm, and then timer override with some emergency storage above that alarm float. So got to have all this fitting in there inside my dose system for this. Now, how much deviation? We talked about with our installer classes for grade 2 and grade 4, we talk about gravel trenches and chamber and easy flow trenches, large diameter pipe. How much fall is allowed on the bottom of a trench. And so our traditional trenches, we want to be as level as possible. We can never go uphill at all, but we can go maybe a quarter inch every 10 feet on some of our products, some only an inch over 100 feet, but no uphill, only a little bit of downhill. Drip is different. Drip allows some plus or minus variation. The plus means I can literally go uphill up to 2 inches in any segment or downhill up to 2 inches. So plus or minus 2 inches from dead level is going to be considered level in a drip system. So I can have some deviation. I don't want long extended slope where water would move down to one end of the tubing. But this humps and bumps almost acts as little dams or check dams along the way. So not a bad thing and not something we're afraid of with drip. So we try to get them as level as possible. They're still going to be on contour, but I can deviate my trench depth just a little bit. I can't go deeper than my maximum trench depth though. So if you got a 8-inch trench depth, that plus or minus 2 inches of variation can't push you deeper than 8. And we've got to have at least 6 inches of soil cover on top of the drip tubing. All right, our setbacks. Let's jump into setbacks. Once again, a 5-foot setback away from a foundation that does not have a drain around it. Post, pillars, slab construction, 5-foot setback. As soon as we put drainage around it, different ball game there. Speaking of drainage, basements are likely to have drainage around them. We're going to have a 15-foot setback away from basements or cellars with the trenches, the tankage, and any distribution device. In-ground swimming pools, we're going to be 15 feet away. Above grounds, we're going to be 5 feet away. If it's got a deck around it, we're going to stay 5 feet away from that deck. Our interceptor drains, these are curtain drains, but it also, if you notice, includes foundation drains in this definitions. So if I've got a foundation that has a foundation drain that's relatively deep, 2 feet or more, then and that drain is below my septic component, where my septic component sits above it, I would need to maintain a 15-foot setback to ensure that that wastewater does not go downhill into that drainage device and not receive proper treatment. If my French drain, interceptor drain, or foundation drain is at the same elevation or it is above my septic component, it's at the same or above, now I'm less worried about sewage going uphill to get into that foundation drain. I could be as close as 10 feet away from that foundation drain or interceptor or French drain. Geothermal wells. I have a 15-foot setback for vertical and horizontal geothermal wells. The boundary around a graveyard, I'm going to be 10 feet away from the boundary areas. Need to understand, and I think as a PCI inspector, you need to have a command over all your setbacks. So definitely take a chance to review your setbacks in the rule book. Just highlighted a few I thought you might see commonly. One thing, just to make sure it doesn't come across as a trick question, recent legislation outlawed the setback or eliminated the setback to underground utilities. So for whatever reason, North Carolina, we have no setback to underground utilities, and that is in law. So there shall be no setback to buried underground utilities in the rule. Not a trick. That's real. As crazy as that sounds. All right, where do we measure setbacks on fill systems or mound systems? So unlike every other system we talk about where we measure from the edge of the trench media, the edge of the ditch, this one we're measuring from the projected toe slope. And on a fill system, we've got a 5-foot minimum buffer from the edge of the trench media to where the fill pad breaks to its side slope. And then we may have a 6 or an 8-foot or a 3-to-1 or 4-to-1 rise to run off of there. So in this case, I got 13 extra feet on every system before I even start measuring my setback. So setbacks measured from the projected toe slope of our fill systems. All right, septic tanks, what do we need to know about them? We need to know what happens in there. Anaerobic decomposition happens in the septic tank. I get a breakdown of solid material, breakdown into carbon dioxide and water primarily, with some off-gassing of methane and hydrogen sulfide. Methane, highly flammable gas. Hydrogen sulfide, corrosive. We're going to find out when we talk pumps, something that we really need to be aware of, keeping out of our controls. but also a toxic gas, one that will kill you, is associated with low oxygen environments. But one of the reasons we're not going to be putting our head down in tanks. The tank itself is required to be watertight in North Carolina. It's going to receive that wastewater from the source, and it's going to start the separation process. We're going to separate out solids from liquids in this tank. We're going to get the solids to settle. Hopefully, the grease and scum, the fats, oils, and grease will float and separate. We're going to get that primary separation. We're also going to get anaerobic decomposition. In these tanks, we've got biology that is robust, that is going to consume the bulk of the solids and leave us with a cleaner, clearer effluent to go out into the drain field where we can cause less clog potentials. So we're going to separate it. We're going to let the bugs chew on it, break those solids down. We're going to have to store some of this because not all of it can be broken down. Some is just the skeletal remains. It's been broken down so many times, it's just can't go anymore. And we're going to have to store that until it's time to pump it out. What goes out to the drain field, once again, we hope is clean and clear, but that depends on the tank being sized appropriately. And so we'll see the minimum size in North Carolina for a septic tank would be 1,000 gallons. And we'd go up there in volume to maintain detention time. So 4-bedroom house, 120 gallons per day times 480 would be the maximum flow in a 4-bedroom. That house can use a 1,000-gallon tank. That means if we started with an empty tank, day one, we would have 480 gallons go into that tank. Day two, 480 more. Even at the end of day two, we haven't sent any water to the drain field. We have ensured a concept of 2 days or 48 hours of detention time to allow the solids to separate, to allow the grease and scum to float off, and to allow biological breakdown of that waste so that only the cleanest, clearest water goes out. As the design flow increases, as number of bedrooms increase on a residence, the tank size is going to increase as well. All right. When do we need risers on a septic tank? Well, some people would say you need them always. Our rules say you need them when the tank is going to be buried deeper than 6 inches. So if we're going to set a tank deeper than 6, I have to get within 6 on the septic tank to ensure access for pumping. If we're buried deeper than 3 feet, then I'm going to need a special tank. I'm going to need a tank engineered in a way that it can withstand the soil load, the weight of the soil on top of that tank. And we often call that a traffic rated or engineered tank, but we're going to need that special tank if there's more than 36 inches of soil cover on top. Septic tanks must have an effluent filter after January 1st, 1999. So we're going to put an effluent filter on the outlet end of these septic tanks to further make sure that I don't have floating solids make it to the drain field. Concrete on that tank is going to be 4,000 PSI by 28 days or 3,500 before it leaves the tank yard. Not our problem. This is the responsibility of the manufacturer to verify that hardness. How much fall is required on a septic tank? Well, I've got to have 2 inches of elevation difference between the inlet and outlet at a minimum. I could have a little bit more, but we could have at least 2. In almost all my tanks, especially concrete, 2 inches built into those tanks. And so it's 2 inch, the inlet penetration is constructed 2 inches higher than the outlet. I can have a little bit of fall. Our rules say that the tank's got to be installed level, and in our rules it says level means plus or minus 1 inch. So it could be a little to the left, a little to the right. We could be 1 inch off. I could even fall an inch and have 3 inches of difference between the inlet and outlet. That's okay. But what if I had backfall on it? And so now instead of 2 inch separation, I only have 1. You would say, well, that's less than 2 inches or less than 1 inch of deviation. No, you got to have at least 2 inches inlet outlet, plus or minus an inch, as long as you maintain that. All right. How much fall do I need and what constitutes a failing system? So in our rules over the years, we've kind of had this concept of having enough fall to get to the system, but that's not adequate under our new rules. So our new rules require that the system has to be fully utilized without backing anything up. In fact, we consider it a failing system if we back up any wastewater into the system. And our new rules define this very strictly as a failing system is considered a backup of sewage or effluent in the facility. That's obvious. If it backs up in the shower pans, It definitely looks and smells like a failure. Backup of wastewater into the building drains, failure, malfunctioning system. Back up into the collection system, that's going to be the piping prior to the septic tank. The freeboard volume of the septic tank, if any of that airspace, if we don't have that 2 inches of open airspace, failing system, and even under modern rules, a backup of wastewater into the distribution device, the D box, is considered a malfunctioning system. And so if we don't set the distribution box and the tank with enough elevation, enough fall to allow completion of that trench, um, full 12 inches of ponding, then you've basically stole inches from your customer. Because as soon as it backs up in the D box, it's a malfunctioning system. Need to understand where that line is as we move forward in permitting, so we know how we're supposed to design or build these systems. All right, if we're inspecting plastic tanks, what are the rules of the road? Well, the approval documents are going to be what we need to look at to make sure it's installed properly. Across all manufacturers approved in North Carolina, we're going to have to do an overdig on a plastic tank. A minimum of an 18-inch overdig to allow proper compaction and 6 to 12-inch lifts coming up from the bottom to make sure we got soil in the corrugations to give the tanks the structural integrity they need. Just like concrete tanks, these tanks are going to be required to have a maximum or allowed to have a maximum of 36 inches of soil on top. Any deeper, we're outside the range of where we want to use these on new construction. So, maximum of 36 inches of soil cover on our plastic tanks in new construction. The pipe that leaves that tank, how much fall, what am I looking for on the gravity supply lines that leave the tank and head towards the drain field or D box? So we're going to be using typically 3 inch or 4 inch Schedule 40 PVC pipe. An eighth of an inch per foot of fall is a minimum. Now, make sure we don't get mixed up here with maximum fall, minimum fall. Maximum fall is a trench concept. We want our trenches to be as level as possible. Our pipes, the PVC, we want it to have some fall to allow water to move quickly and not have clogs. An eighth of an inch per foot minimum. Every 8 feet, I need an inch. If I had 80 feet, I'd need 10 inches. And so these are minimums. I can have more. I cannot have less. How much cover do I need on these supply lines? I need 6 inches of cover over the crown of that supply line. So all the components of a wastewater system are going to need at least 6 inches of cover, with a very few exceptions out there. 6 inches of soil cover required over the top of a gravity supply line. All right, let's jump into some of the individual products, understand what the rules are for those guys, how they work, how they function, and what we can do to make sure we're inspecting these in accordance with the design approvals in North Carolina. Easy flow, styrofoam peanuts. We're talking void space achieved by an aggregate wrapped around a pipe in the center bundle and a geotextile fabric over the top, netting to hold it all together. This works out in our most common application is going to be 3 feet wide, 1 foot deep, typically a replacement for rock and pipe. It comes in 3 foot sections, 5 foot sections, 7 and 10. As a PCI, you are not supposed to allow the field cutting of this. If they want to get 42 feet, they need to get a 3 10-foot sections, a 7 foot, and a 5 foot section, because with the 3, 5, 7, and 10, you can make any length you need to. We need to understand how trench depth plays with the reductions. If I can get a 25% reduction with this product versus gravel, and that's what a lot of these are designed for that you'll be inspecting. But if I go deeper than 36-inch trench depths, I lose that reduction. I don't have the reduction anymore. Now I'm foot per foot with gravel. And so that 36-inch depth, that's 24 inches of soil cover, is going to be a critical point on these. If I go deeper than that, I lose a reduction. I can still use the product all the way down to 60 inches. Below 60 inches, product's not allowed to be used in North Carolina on new construction. So maximum trench depth of 60 inches, that's 48 inches of soil cover. But at 36, I lose my reduction. This product goes on 9-foot centers typically. 3-foot wide trenches, 9-foot centers. We're going to see that concept repeat itself. Large diameter pipe. So we've got a corrugated pipe with a series of holes in it, strategically placed, to allow for better distribution and uniform movement of water down that line, that's wrapped in a geotextile fabric. And so, a couple key concepts here to think about. The first is we're not going to use this on a high fat soils grease concept. Restaurant application, church kitchen those would be applications I would expect to find higher levels of fat soils and grease. It comes in an 8-inch and 10-inch version. These are inside diameters. The 10-inch goes in a minimum of a 12-inch wide trench. The 8-inch goes in a minimum of a 10-inch wide trench. The 10-inch that's made by Crumpler is technically one that could be used as an accepted product to switch out for rocker pipe. But remember, as a PCI, we're there to execute the design plans as drawn up by the engineer or AOWE. If the engineer or AOWE has written the permit for rock and pipe, the accepted status for all of these products is kind of on the shelf. It is up to the engineer or AOWE what products they allow in this design, and you would have to get written approval before you allowed the switching or swapping of any of these products. All right, center spacing. We said the Easy Flow, the 3-foot wide product, went on 9-foot centers. Well, the 8-inch that goes maybe as small as a 10-inch, it goes on a 5-foot minimum center to center spacing, and the 10-inch goes on a minimum 6-foot center to center spacing. Max LTAR 0.8, but thing to think about in the field, 1 inch of fall per 100 feet is the maximum. We're going to look and make sure this product is installed as level as possible, and the product is installed with the stripe up. That's going to keep the holes in the position they need to be in to provide for uniform distribution down that trench. 2-foot wide chambers. You'll see the product EQ36 is equivalent to a 3-foot wide trench. This product gets no reduction in linear footage. If it was going to be a 400-foot rock system, it's going to be a 400-foot, 2-foot wide chamber system. The reduction in this comes in center spacing. We're going to move from that world of 9-foot center to center to 6-foot center spacing minimum here. This product needs to be walked in like we'll see in all the chamber products. I need soil integrated around this product to allow for to prevent damage during the backfill. End caps. I get 1 foot of credit per end cap. The end cap on this guy right here is not going to be something that I can put in the middle of the trench. It's going to go on the end, so a foot per end cap. Got to be walked in, no reduction in length. The low profile chamber. So this specialty tool is primarily used in eastern North Carolina, but I see it show up in different parts of the state. 8 inches tall, 3 foot wide, 4 foot long. The center spacing, because it's a 3 foot wide product, is going to go back like the standard chamber. It's going to go back to a 9-foot center spacing. It gets 1 foot of credit for end caps that are used in the center of the trench, but the 2 on each end, those 2 are only going to get 6 inches each. So a foot of credit for a pair of end caps and 1 additional foot for each end cap used in the middle of the ditch. Got to be walked in. Not going to get a reduction in linear footage on this one. This is one that we're going to go foot per foot with gravel. The standard chamber gets a 25% reduction, but the same rules as Easy Flow. We're going to lose that reduction below 36 inches, below 24 inches of soil cover, and we're going to not be able to use the standard chamber at all below 60 inches of trench depth. All right, so we've got some basics here. You need to know what you can do as a PCI. You need to know time frames. You need to know how many hours a year you need classes, the basics we saw. Then you need to know how to inspect some system components, some basic setbacks. I'd look over my setbacks, look over your basics of system design and inspection. Good luck on the test. Hope you guys do well. I'll see you soon.